Alright guys, so this is an answer key to simplifying rational expressions part 2. It says equations, it should say expressions. An expression is where it's not equal to y. An equation is where it is. As you can see, these are not equal to y. These expressions are not equal to y, so it should be expressions. Okay, my mistake. So in this case, even though the title of the homework is Simplifying Rational Expressions Part 2, we were doing something a little bit more specific than that. We were finding the excluded values. And remember, an excluded value is a value that has to be excluded because it makes the whole expression undefined. So what m makes this whole expression undefined? The answer is an m that makes the denominator 0. Okay, so this is the same thing as finding the zeros of just the denominator. I'm trying to figure out what m's give me a denominator of 0. In this case, it's easy enough. Subtract by 5 on both sides. I'm going to find that m is equal to negative 5. So my excluded value is 5. Only one excluded value in this case. Okay, move on to problem 2. I'm just finding the zeros of the denominator, because whatever values make the denominator 0, I'm going to call my excluded values, because they make the rational expression undefined. So how would I solve for this? Well, I can't just solve for it because it's got a squared here and the first power term here, so I got to try to factor it. First thing I always try when I factor is finding the GCF. So what comes out of 3 and negative 24? I think I can take 3 out of both those terms. Also, both terms have an m. I can take an m out. If I divide 3m squared by m, I get m. If I divide negative 24m by 3m, I get, what would that be? 24 divided by 3 is 8. So just 8. Okay. Now I can solve each factor independently, because if either factor equals 0, that's a possible solution. So in this case, m is going to equal 0. In this case, m, if I add 8 to both sides, is going to equal 8. So my excluded values are 0 and 8. Very good. Okay, same deal over here. Denominator equals 0. Find my excluded values. I'm going to try to take out a GCF. I think I can take out a 7x. What's left behind is x minus 2. Set both equal to 0. Divide by 7, x is equal to 0. Add 2, x is equal to 2. My excluded values are 0 and 2. Alright, this one's a little trickier. Set my denominator equal to 0, 2k squared plus 11k plus 12. Now, to factor this expression, I could try a GCF, but nothing divides out of 2 and 11 and 12. And I could try taking a variable out, but this last term doesn't have a k, so I can't take a variable out as my GCF either. I've got to move on to another factoring technique. Let me try AC method, because it's got 3 terms. I'm going to take my A and my B and multiply them together. 24. Going to find factor pairs of 24, especially looking for one that adds up to be 11. Okay? So let me try 6. What could I try? 6 and I'll just try 2 and 12 and work my way up from there. 2 times 12, but that doesn't add up to 11. Okay, so what about 3? 3 multiplies by 8. Yes, okay. So this is the pair that I want because it adds up to 11 and it multiplies to be 24. So now I can group 3k plus 8. 3k and 8k, that's for my factored pair. It replaces the 11k that was above it. Okay, now I can group. Okay, so 2k squared and 3k, k can come out of that, leaving 2k plus 3 behind. 8k plus 12, I can take a 4 out of that, leaving k plus 3, sorry, 2k plus 3 behind. Okay, now my matching factor can come to the outside, and my leftover factors come together to form the second factor. Okay, now that's the factored form. It equals 0, which means that both factors could equal 0, and I'm going to get two possible solutions here. Okay, now please don't mind my lowercase k's. I know they look like r's. It's just how I was taught in kindergarten. It's a hard habit to break. Okay, I'm just solving both of these expressions. So over here I got k equals -4, and over here if I divide both sides by 2, I'm going to get that k is equal to -3/2, which means my excluded values are -4 and -3/2. Those are my excluded values. These values make the denominator equal to 0, which make me have no solutions for those values. That's why I have to exclude them. Okay, one last one. I got to write a little bit tighter for this one because I'm running out of space on the paper. So, again, setting my denominator equal to 0. It's 21 m squared plus 30 m. Okay, so first thing I look for is a GCF. Can anything come out of 3 and 21 and 30? Yes, indeed. I can take a 3 out of all of those terms. Also, can I take a variable out? Are there m's in every term? Yes, there are. So I can take an m out. Okay. What's left behind is m squared plus 7m plus 10. Now my a times c now. So I've got a trinomial left, 3 terms, which means I got to still use AC method on this. A is 1, C is 10, so 1 times 10 is 10. Okay, find some factor pairs, especially that adds up to 7. I think I'm going to choose 2 and 5. 2 and 5 multiplied to 10 add up to 7. So let's do m squared plus 2m plus 5m plus 10. Okay. Now I'll group those together, group those guys together. I've got 3m times, this is going to be m times m plus 2. This is going to be 5 times m plus 2. Okay? So that means that all my factors together are 3m, m plus 2, and m plus 5. Okay? Now, if I set each of these factors equal to 0, because this whole thing equals 0, this is just a factored form of my denominator. If each of these factors equals 0, I could figure that out, set them equal to 0, and solve just like my other problems. I'm going to find out that my excluded values here are 0. That's going to come from this factor. M would have to equal 0 if I wanted this factor to equal 0. -2, okay, that comes from this factor. If I put -2 in here, this factor would be equal to 0. And then also -5. -5 comes from this factor. If I put -5 in here, this factor would equal to 0. So these are my excluded values. And if I wanted to write all that out, I could write that all out where I just set my factors equal to 0 like I did up here and solved. So there are the solutions.